Hey, it's Raimu. It's stream number 26. Almost done with this keyboard. I haven't done all the LEDs yet, but I've just about finished all the other tasks. There's one I want to finish today, and that is saving and loading the key configuration. So it all has to do with reserving some area of flash and then saving and loading it. So let's work on that today. As extra credit, I don't know if I'll do this on stream or not, but it would be nice to have a GUI for editing the key config. But without the GUI, I'm pretty much okay with just editing it in the IBC module here. I have the key configs. So, I mean, it's not very easy to find keys in here, but I don't think I'm going to be changing keys around too much. I haven't really needed to change stuff on my Corn keyboard for a long time. I'm gonna do some LED logic at some point. That'll actually probably be the last stream unless I do this on stream. I still have this problem where when I connect to my keyboard serial port, it takes 30 seconds to connect sometimes. And I got a little bit of a hint today, just running Wireshark, that it might have to do with while it's setting up the line configuration, it's taking almost exactly 30 seconds to reply. So I think somewhere there's some kind of bug where there's a 30-second timeout, and I haven't been able to find such a 30-second timeout anywhere. And I thought it was a Windows-only problem, but I was connecting to my MacBook earlier, and it has the same issue. So I don't know if it's exactly 30 seconds there or not, but it seemed like it. I don't think I'm actually going to do this combos according, so I'm going to cross that one out, because I thought about it earlier and like, I don't really need that feature. Maybe someday if I do have such a feature, I will add it, but we'll just cross it off the list. Hey there, Perkin J, how are you doing? You are the first. Well, except for my bot. But you're the first on the chat overlay. So there you go. So yeah, everything's checked off. I think maybe using the second CPU core will be extra credit once I have the LED logic. Depending on how much time the LED logic takes, this might be convenient to do in that second core. And I don't think I'm going to actually do this one after all, because I don't really see a point. I don't usually turn my computer to a sleep mode or suspend. I usually just turn it off and they don't really care. Hey there, Gamer Chris plus Pinball. Didn't I see you on a different stream? Like, weren't you on, hold on. Another stream that I followed that I was looking today. Weren't you on Jitspo's stream not too long ago? Idle just be blocking the loop? You mean, why would we use the CPU core? Yeah, because the smart LED stuff, it busy waits while it's doing the timing for the LEDs. And if I wanted to, I could take charge of the timing myself, but it's just too complicated. I might as well see if I can use the second CPU core for that. Yeah, I know. Well, that's fine. Feel free to browse through the Twitch channels. We're not going to be doing any game development today or any Godot. This is all going to be Rust code. Running in this. Oh, I don't know if anyone's noticed yet, but I've 3D printed this part. That little cap that goes over the controller. So now there's like spill and dust protection. So here's what it looks like. Pretty cool, right? It's got a little hole there for the USB port. And I put a little lip there. It's kind of hard to see on the camera. But I don't know, I felt like doing that over the weekend. So let's show you what it looks like. Just to prove to you, I did model this and print it out myself. I don't know why I feel don't know why I feel the need to prove it, but hey, it's kind of cool. I don't know why I had that on. But yeah, there it is. Modeled that. It didn't take very long. There's that little lip I talked about. Turns out I didn't really need that because it was a tight fit anyway, and that was just to help it snap in place. I think it does help a little bit, but I had to like shave it down like to maybe 1/4 millimeter before it actually fit. Not proved, documenting, there we go. Nylon question mark? I don't know what that was for, but yeah, I'm using I use Blender for the 3D modeling for all the 3D printed parts you see here. So these controller caps, the last thing I did, these plates that hold the switches on, and then the plate at the bottom that everything rests on top of. All 3D printed, modeled in Blender. Alright, so today I was going to work on what again? Oh yeah, so reserving some area flash for a key config block. Alright, so it's marked with my to-dos here, right? So here we receive the key configuration from the computer, and right now we just update it in RAM, but we don't actually save it. And then over here is where we would load it from Flash, and if what we load from Flash doesn't parse, then we would fall back on the key configs from the IBC crate, which is what the programmer is going to be using anyway. Hey there, Neg Borsa. How are you doing? What type of plastic did I use? It's PLA plastic. It's supposed to be transparent, but it comes out sort of like a frosty white. Especially apparent if you see how the LED shines through it. It's like not exactly clear. It's got like a hash pattern. A friend of mine thought it looked like a frozen castle up close. Yeah, PLA. It's biodegradable. It melts at around like 215, 220 Celsius. I have an old reel of it, so it's sort of brittle, but I got it to print anyway. Oh, you're saying it looked like nylon? No, it's yeah, PLA plastic. I also have a reel of ABS, but I hear that's pretty toxic, so I don't want to use it. Yeah, I think it is made out of some vegetable, maybe corn. Typing on sugar cubes, yeah. No, this is in case I drop my beer on this. Now it's semi-protected. Okay, loading key configs. So let's make this the alternate. So hold on. If this is now in the IBC crate, I kind of want to rename it. We'll call it the renaming alias is currently not supported. Really? Okay, how about load default? I'll try the stream to use the new keyboard as much as possible. So this is what we're going to do if the other one fails. So I think then what we want to do is we want to try to load key configs, which we haven't defined yet. And then we would do OK or else. Oops. Okay. So this needs to be a function that returns a result, right? How come, there we go. Where am I going to put this? Maybe it should go in Flash. Maybe? I mean, it's as good a home as any, right? Pub, a function. Key configs, right? Let's make it an option since I don't believe in errors for embedded firmware tonight. Okay. And then all left is to import this from Flash. Okay. And then let's get rid of the to-do since I kind of moved that. Okay, that's fine. So where's the other to-do? Right here. So write to Flash here. Okay, so save. Key configs. Configs. Probably borrowed, right? It's past midnight. East estimated timetables, temp tables you're working on just dropped. Hey, the Nightshade dude. I hope it was okay that your temp tables got dropped. All right. Pog function. Okay. Import from Flash. Okay. Cool. So we need to reserve an area for this, right? Where did I place the staging area for firmware updates? They still call it staging? Yeah, staging offset. Okay, I put it in programmer. Okay. Now, is that halfway? I can't remember. Programmer calculator, please, in hex 40 and then 4 zeros. Four megabytes? And how much flash do we have total? We have 8. Minus 100 for the boot area. Okay, why don't I just put it at the end of flash then? Wouldn't that make the most sense? Just put it in the last sector of flash. So that would be, you know, times 2. Oops. I should have done this in decimal. Okay, 80, well, 10, well, 100,000 in hex. That's a megabyte, right? Yeah. Okay, so then, okay. What am I doing? What am I doing? I'm lost. Yeah, here. Okay. I guess I'll just put it here. This is the base address in Flash, where we will store our keyboard configuration. Duh. Oh, hold on. Gotta take this call. All right, sorry about that. So hold on. So what to call this? What to call it indeed? Keyboard config base. So I think we just want to take the end of flash minus the sector size. It's interesting that Rust lets me do this where we can use something before it's actually declared. So this will be 7FF000. Okay, cool. Make sure I understand this correctly. So the offset doesn't have the flash base in it. So when we call program sector, we want to subtract flash base from whatever address we send, right? Okay. All right. Midnight Eastern said, database is set to drop temp tables at midnight. Won't that disrupt like work that's happening around midnight? I mean, that's when programmers are the most productive, or is around midnight, right? Program sector. Okay, so yeah, we got it. Okay. What's interesting is that we're going to receive these key configs deserialized. Now we're going to end up serializing them again, right? So the monitor does the serialization we know works. So let me find where that is. But you put them into a volatile space expected. You could put into a non-volatile space if you need persistence. Okay. Well, I guess that means if you're working late, don't use volatile database storage. Aha, here we go. We don't need to codec encode it though. I really only need to encode the message. So that's this, right? So let the sector equal this. Oh, we don't have bin code. Well, I guess it's okay. We can import bin code. Using it in IBC, right? We just want to include the same... Oh, actually, I don't need the derive feature, do I? Well, I think we do need to specify it. Actually, no, I don't. I think I can just get away with... Looks like the versions of some of my libraries are up to date now. Critical section moved to 1.0. Wow. Atomic polyfill went to 1.0 also? Huh. Interesting. Okay, but for this I only really need to say this, right? Okay. Is this building then? No. Let's just hit save again. So we can run Clippy again. Nope, do I need to restart it? I think I do. Restart server. Sometimes I get this where I change the cargo toml and then I will save and the Rust analyzer needs to like be reset. And then save again, right? Okay, maybe it's not here? And where is it? Oh. Okay, yeah, then I do need to reference it exactly the way it's referenced in IBC then. Right, because the default feature is to include the standard library, which we don't have. But I can remove these features, right? I can do that at least. Still no? No, it's mismatched types again. Okay, so we're back. Okay. Fix the one thing, and here's the other thing. Right, so this is key configs, right? Cool. That fixed that. Wait, hold on. Is the type here wrong? Oh, it's a result. Oh, shoot. Okay. Is it okay or else? Also returns a result? Oh, doesn't that need to be unwrap? Or? Else? Yes. Okay, that works. All right, so then we have the sector, and we need to make sure it's expanded to be the sector size, right? So, is it just resize? Oh, this is a result. Okay, that's just unwrap that. Should get a vector. Cool. So that vector needs to be expanded or resized, right? So we want to resize to sector size. And with zeros is fine. Because I think that programmer expects that. What I can't... oh, as usize. It needs to be mutable. Not a nut, a mute. Okay, yeah, and then the final step is to do the programming. So I think it's just as easy as just calling this function I made, program sector. Oh, it wants an array. That's important, yeah. So in the other places I think I do try and to unwrap. Yeah, so kind of like this. Yeah. Program sector, and the offset is going to be this keyboard config base. I think that's it. So then load is really easy, right? I just need to get a pointer to that address. So we do that in here. And this whole thing is unsafe, so we'll put this into a unsafe block. Huh. Why did I do it like that? I wonder why I did it that way. I probably don't need to do it that way. I think I just need to get access to the array as is. So hold on, what if I just do this? Ah. It doesn't need to be mutable. Yeah, so I need to take the flash base and add the keyboard config base, and we're going to transmute it to be a constant pointer to bytes. I forget how to do this, but shouldn't I be able to then turn it into a reference to U8 of size sector size? Why resize with 0 and not 0xFF? Good point. Yeah, because typically flashes are erased with FFs, and it actually a 0 is changing the state of that part of the sector, right? So it's less energy to keep it at FF. Good point. Oh, okay, I forget how to do this. Maybe I've done this already somewhere elsewhere in the code, so let's search for it. Is this how I did it? I did core slice from raw parts. Yeah, let's do that. Yeah. And sector size is this. Okay. This like esoteric low-level stuff, I'm not so familiar with how to do it in Rust. This gets me what I want, right? Because once I have a slice, I can then just do the equivalent of, well, the opposite of encode to vec. That we do in IBC, right? Decode from slice. Right. And we get a... All right, so we need an array? Really? No, it's just something that we can decode. Why did I use an array like that? Oh, that's the encoded message. Okay. I don't know why I used message size. It should be encode decode from slice sector. That gives me a result. So then we would do OK. Or we'll do and then, right? Oh, no, it's just okay. I think. And then it's gonna be like, we need one of those two things, right? Right, so it's .0. No field 0 in option. Oh, I guess it's just map key configs and message size, or bytes decoded to key configs, and then I don't need the bytes decoded, so I'll put an underscore in front of that. Sorry, slipping on the keyboard. Okay, there we go. How does that look? So saving is taking the key configs, encoding it to a vector with bin code, resizing it up to the sector size, and then calling program sector. I'm guessing program sector, yeah, it needs to be that size. Otherwise, we will crash on the unwrap. When we're done programming, we should be good. Maybe print a message before and after. Just because I'm curious to see how long things take. Saving key configuration to flash. Okay. Loading key configurations from Flash. So here we got to say like let maybe key configs. We can say if it... Maybe key configs is some. Else... Let's do a warning here. We haven't done a warning at all in the code yet. So, unable to load key configurations from Flash. There we go. All right. These are both from log. Cool. Let's give this a try. Program after we build. Okay, we gotta wait the 30-second wait of doom. The 30-second timeout I haven't found yet. It's like take a sip of drink break for 30 seconds. So if this should like fail to load it, but then when we run the program, well, when we run the monitor program and tell it to load to transfer the key configuration, then it should save it, and the next time we reset, it should load it again. And this is only going to save it on the left-hand keyboard. So yeah, I guess I gotta wait another 30 seconds for it to connect again. But it should say it failed, right? It didn't crash, which is good. It should have tried to load it and failed, though. I guess while waiting for that... Oh, there we go. Unable to load it. Or why did the right-hand keyboard do that? It doesn't even need to. I guess, yeah, I guess the right-hand keyboard is doing it even though it doesn't need to. Alright, well, let's try loading it. I don't have a batch file to do this. I should make one, right? So it's kind of like log or program. Kind of like program. So let's copy paste that and I'll call this one, oops, escape. Call this one config. I like config. So instead of dash dash program, it's just going to be dash lowercase l. Okay, and then we're going to run config. Nope, it did it. Okay, so it took about 60 milliseconds. Interesting. That confirms that that each flash sector takes 60 milliseconds to write to. A little bit more than 60. How much did we estimate before? Max sector programming time, microseconds, we guessed 100 milliseconds. Conservative estimate. So I guess I could trim this down to 70 if I wanted to, like speed up flash programming. Okay, now the true test is to reset this guy. Unfortunately, I have this cap on top, so I can't get to it. But I guess another way to do it would be to unplug it and plug it back in again. There we go. Oh, look at that. Successfully loaded key configurations from Flash. All right. Now, does it actually work? Looks like it works. Cool, so a test would be to, without reprogramming the Flash, to just change a key. So what's a key we could change? Over in IBC, key configs. I think the one I did yesterday, or the day before I mean, was I like just made the Z key into X or something like that. Yeah. So if I just change, X is up here, right? Is 1B? Yeah. So if I just change that one character from a D to a B, now Z, what was Z will become another X key. I'm not very creative. If you haven't figured that out yet, I'm not the most creative person. So this is rebuilding the monitor because it's actually built into the monitor right now. And it did it. It saved it. So it should have taken effect in RAM. So if I hit it now, it's X instead of Z. So now I have two X keys. But here's the real trick, is if I unplug it and plug it back in, it'll stay at X. Yep. It's permanent. Does encoding take time? Not really. You think it was S on line 361? Oh, you're probably right. You have a better memory than me. Yeah, did I turn X into S? Yeah. All right, well, let's fix it. Where was I? There. So save it again and just reconfigure. And this time we have to wait the 30 seconds. Excuse to drink. So we can actually see how long the encoding takes by how long this says between saving and saving done. Oh, wait a minute. No, it won't. Not unless I add another message before we reprogram Flash. I guess just out of curiosity we could do that. But then let's try to do some, let's try to actually measure it really precisely, because there's some overhead in actually logging messages. So actually what I would like to do is log the same message twice, then encode, and then log it a third time. Oh, testo. Yeah, it's back to normal, and turning it off and on. It's persistent. Cool. So then, yeah, just out of curiosity, let's look and see. Yeah, because logging has overhead, what I think I'll do is do it twice, and then this final one will, let's just put 1, 2, 3, and then basically we'll take the difference in timestamps between these two and subtract the difference in timestamps between these two, and that'll give us how much time it actually took to do this step. It is doing some memory allocation, so it's going to time the memory allocation plus the encoding. I don't think it's going to end up being very much time at all. It's going to be on the order of microseconds, but we'll find out. So here we go. We didn't get the 30-second delay this time. Reprogramming now. But now we got the 30-second delay. It's always something. It's always some scheme to slow me down. I guess while we're waiting for that, I can undo that because we don't really need that, and I'll just check the code in. So I'm going to check that in and say we're done with this task. So that we want. I'll have that as a different commit. That we want. That and this. Git commit. Is this done yet? Oh, it's done. Wait. Okay, hold on. I scrolled too far up. Okay, just making sure it's successfully loaded from Flash. Okay, cool. The deserialization takes a little under 2 milliseconds on success, and on a failure, it took about, what is that? 680 microseconds, so under a millisecond. About 2 milliseconds on a successful run. Okay, so this is load and save keyboard configurations. Okay, and then I'm gonna run the config so we can get it to tell us how long it takes. So there we go. So these two minus these two. So logging the message by itself takes 210 microseconds, right? So actually doing the encoding took 1,700 microseconds. So subtract 2 from that. 1.5 milliseconds. Okay, so it's a bit longer than I thought. I thought it'd be on the order of microseconds, but it's on the order of a millisecond. 1.5 milliseconds to encode. 1.5 milliseconds to encode, and then, yeah, it's pretty clear. It's taking 60 milliseconds to write to Flash, to erase the sector and to write it. 60 milliseconds. Almost exactly. 60.2. Or 60.18, if you want to be precise. Okay. Okay, I'm done with that test then. I'm done. Okay, so I don't want to work on that until I've done the soldering of all the LEDs. And this is extra credit. It's going to take a bit of research first. And this, I don't want to look at that anymore today. I spent enough time on that before the stream. And the second CPU core, I want to wait till I have the LEDs done. And I'm done with the combo. So I'm done with all the feature work until I do some LED soldering, or I feel like looking into this problem. So I think for the rest of the stream, I want to do some refactoring. I haven't done refactoring in quite a while. Basically, it's cleaning up my code to make it easier to maintain and understand. So you have to do this occasionally. I have to do it a lot because a lot of the I have a bad habit of writing ugly code that needs refactoring almost immediately. Cool. Still successfully loading the config from Flash. Interesting. So that time it took 1.7 milliseconds. It's interesting that it takes... Like, it really shouldn't be... The decoding shouldn't be that much more than encoding, but I guess it is. Interesting. Anyway, let's do some refactoring. Let's close everything. Let me make sure that everything outside of keyboard is pretty good. So let's look at arc. Yeah, that's fine. Controller state. We could refactor this out because there's a little bit too much indentation here. Yeah, let's do that. So I think the way I want to refactor it is each of these arms becomes its own function within controller state. So that's this whole thing, right? Extract into function. It shouldn't have put the function there, though. Because doesn't that use self? I guess it doesn't. Huh. Wait a minute, it's returning controller state? Oh, because it's consuming self. Okay, cool. So it doesn't even need to be in the implementation of controller state. So what am I going to call this? This is controller state next in the normal state. Hey there, Tribute Dev. Am I making a driver for the keyboard? Yeah, I am. In fact, I made this keyboard. So it's taken 26 streams plus a bunch of off-stream work, but I made this pretty much from scratch, and I'm pretty much done with the firmware now. It's all written in Rust, like these little icons kind of imply. That's the Ferris logo and the Rust logo. So if you want, I can talk more about that, or I can show some of the other stuff. But yeah, we did circuit board design. I did 3D modeling for the 3D printed pieces. And the firmware is not completely from scratch. It's not like bare metal. It's based off of some libraries for the microcontroller we use. So it's an Adafruit KB2040, which has a Raspberry Pi microcontroller on it. And we also use an open source Rust USB stack for both human interface device, which is the keyboard. If we wanted to, we could emulate a mouse, but I'm not doing that. We also use a serial port, and I also use a couple libraries for the LEDs. I use these smart LEDs called the NeoPixel, or the WS2812s. So I have some libraries that do that, but everything else I wrote myself. And it's all archived on YouTube if you really wanted to see all of it, although I don't expect people to do that. I think I'm going to make a wrap-up or the highlights video, maybe half an hour, 45 minutes, that goes through the important parts. But yeah, I'm pretty much done with all the features, and so I'm refactoring the code now. But let me know if you have any questions or you want me to show you anything. What I would really like to show, because I thought this was really cool at the time, was the circuit board design. So I used KiCad. I just like to show this because it's so cool. So we did all of the footprints, and we laid them all out in space, and we did the routing of all the traces. And the circuit itself is not very complicated. There's a controller board, there's a connector to go between the two halves, and then there are a bunch of these switch LED diode combinations. It kind of matches what the schematic shows. It's really just a bunch of copy-pasted switches with diodes, and then a whole bunch of daisy-chained LEDs. And they're not just simple LEDs, they're like it's like a smart LED. It's 3 LEDs in one, RGB, with a tiny little microcontroller in it. And it does a lot of the heavy lifting for me, so you just daisy chain in a string of RGB values, and it changes the lights. It's very nifty and simplifies things for me. So I like to show this because it looks cool. Hey there, Lazy Guru. Just showing off the circuit board design for my keyboard. I'm doing some more mundane stuff right now, though. I'm refactoring. So this is like update controller state normal. Actually, it should be like normal controller state. Update normal controller state. Or something like that, right? Because it depends on what state we're in. So all of this would be refactored out into like update firmware update controller state. I don't want to do F2. I want to do control dot extract into function. This function F2 update a firmware. I already don't like the names. But let's make sure I can do this and not have any errors. Okay, so then, yeah, that doesn't need to be mutable, does it? It's mutable down here, but doesn't need to be mutable here. So that made this function very simple. It's really just branching to 2 different functions depending on what state we're in. And we're getting back a programmer possibly there. I've only seen a circuit design software one time before. A former colleague of yours really went into this kind of stuff. It's a bit over your head though. If you approach it piece by piece, I think it's easier. So I didn't know anything about this KiCad program until I watched a few hours of YouTube videos. And then if you can like get these symbols plop down and they match the chips you have. So this is like the KB2040. I didn't have one given to me. I sort of had to make one, but there was another YouTube video on how to make a symbol in KiCad. It's just showing you the different signals that come off of it. And I guess the hardest part is if you haven't done electrical engineering stuff before, you might not know what ground is or 3.3 volts or, you know, what a GPIO is. But once you learn like the basic concepts of that stuff, you just drop these symbols down and then you connect them together. So I wanted, for example, the grounds to be connected. So I just wrote these green wires to ground 1, which is my left-hand ground, because these are different boards, obviously. And then I'm like, okay, if I want to connect the grounds of the boards together, then here are the 2 connectors, right? I put ground 1 on one connector, and I put ground 2 on the other connector, and then assuming we connect it with a cable, that connects ground 1 and ground 2 together, right? Same thing with V-bus, that's plus 5 volts. So plus 5 volts 1 and 2. And that gets routed to the raw pin on the controllers. So a key matrix like this is another bit of study you have to do, but like when it comes down to it, it's just a bunch of inputs and a bunch of outputs. I think I have the rows as inputs, columns as outputs, and so we configure 3 of these GPIOs as outputs and 6 of them as inputs. And the NeoPixels are just 1 output each for the whole daisy chain. And they have the same power and ground. And so if you can get that far, that's pretty far. The rest of it is each of these symbols has to have an associated footprint, right? And that would look like this when you place it on the board. So once they all have footprints, you just tell it, hey, place them on the schematics on the PCB editor somewhere, and then you just drag them around. And I didn't know anything about routing these traces around, so I watched some more videos, and some people in chat were helpful. One thing that I wish some of the videos I watched on YouTube would have said more clearly, and the guides that I found Google searches, that what really helps routing on a 2-layer board like this is pick like horizontal for one side and vertical for the other, and it's a lot easier to route without getting a huge mess. You still need a lot of these vias, which are like places where we connect the front and back so we can jump from one side to the other. But it became a lot more fun to lay out these traces that way. I guess this was easier for me because I studied electrical engineering in college, and so I already kind of knew what a ground was and what power was, and GPIOs are like general purpose IO pins. So maybe I kind of take for granted that stuff. Could be. Are those blue circles capacitors? I don't have any capacitors, even though you're supposed to have a capacitor. This is the NeoPixel. It's actually on the back. So let's flip over to the back side. Flipboard view, right? And let's have it show only the back layers. And let's hide the fab layer. So on the back, there are actually two. Here are the kinds of components that are on the back. This thing is a socket for one of these switches. So if I like pull one of these off and show you, you see those two black dots? Actually, it's better if I orient it that way. Yeah, I'm not very good at showing things to the camera. There we go. Those two black dots correspond to that weird L shape, right? And then there's a main circular hole. That's really where the switch's peg sits. And then that rectangle below that is a little hole cut out for there's an LED that shines up through it. So an individual switch here has the 2 pins that go into the socket, and it's got like a plastic peg that sits in this hole. And yeah, this is a cutout in the board, and on the back we mount one of these LEDs. The LEDs have these 4 pins, right? So there's LED, another LED package here. There's the socket for the switch. There's some holes for the pegs of the switch, and then there's a diode. But I didn't actually use any capacitors. The data sheet for these LEDs says you should have a brownout prevention small capacitor, but I noticed that no other keyboard design out there that uses these actually obeys that rule, and so I didn't either. Which is nice because surface-mounted capacitors are really tiny and I didn't want to mess with them, and the board was already crowded enough just with the sockets, 2 kinds of LEDs, and a diode, so I really didn't have a whole lot of room for any other components there. Hey there, 715209. Oh yeah, so you're actually specifically about the blue circles. So these blue circles are just holes. Wherever you see a blue circle, it's a hole in the board. And so if I turn off mask, no, not mask, paste, one of these. Oh, I know what it is. It is pads. So they are called pads in the program, but they are non-plated pads, or non-plated through holes is what they are. Yeah. Hey there. Yeah, I'm not following the rules with capacitance. One thing that I might run into, and it'll teach me a lesson, is I haven't tried with this thing to wire up. I haven't even soldered them all yet. But if I solder in all 40 LEDs, or really per side it's 16 plus 4, so it's 20. If I solder in all 20 LEDs and then have them all turn on simultaneously at their maximum brightness, it could cause a brownout theoretically, because it's going to like all of a sudden draw a whole bunch of current that it wasn't drawing before, and without capacitors it all becomes a huge load on the power really the host, the PC. So we'll have to test. That'll be the stress test, is go from completely dark to completely full illumination on all, like basically full power white on every LED, and we'll see if it causes my PC to shut down or we see brownout issues. Brownout is when the voltage of the power dips below a threshold that is required by the active circuit. So like the CPU cores on this guy, they'll start to malfunction if the voltage drops too low. So brownout usually just causes circuits to reset or just start to malfunction. For a CPU, a malfunction is basically going to crash everything or do something unpredictable. A memory circuit will corrupt. It'll corrupt memory, right? Yeah, so I'm going to hope and pray that I don't actually need to put capacitors on this thing, because the workaround would be that we would power them up slowly so that we don't brown out. But maybe we just get away with it, right? With not having any capacitors. Hey there. How do I say your name? C. Kuden? Fellow WS28, 12 birds there. The LEDs are still very luminous at 50, at what? 50 brightness and or less, yet consume a lot less current. Yeah, so maybe I don't really need the capacitors at all. But here, let me show you. I saw this and I was like wondering how come no one obeys this. So it's in the data sheet for the LEDs. It's in all three of the data sheets that I found here. They like recommend a capacitor. I'm not sure why, because no one uses it. Where does it say it? Maybe it's not this one. Ah. Not here. Okay, maybe I need to search. In addition, in order to make the IC chip is more stable, even the capacitance between beads is essential back. Okay, not the best English. Probably was the other data sheet that was more clear about it. Maybe it wasn't this data sheet. Maybe it was the... it might have... You know what it might have been? Is Adafruit's... or Adafruit's walkthrough. The Adafruit NeoPixel Uber Guide. Yeah, here we go. It's very strongly recommended that each NeoPixel have an accompanying 0.1 microfarad capacitor between plus V, which is the power line, and ground. This prevents communication problems due to brownout of the on-pixel driver logic. It's occasionally significant to have one capacitor between pairs of pixels. So we have 0 capacitors for a string of 16 and then another string of 4. So I'm totally not obeying Adafruit's guide at all. Small cap on the left there. No, I don't know. I'm not sure what you were looking at, but on my board I have no capacitors. And hey there, cheese department. Maybe it was in the data sheet for the NeoPixel. You can also cheat and have one, say, 1 microfarad THT instead of several hundred nanofarads ones, but it's not as good in the most stringent power delivery sense. Hey, maybe the capacitance we have between the traces ends up giving us enough capacitance, right? Because we do have a lot of traces, and some of them are carrying power and others are carrying ground. Hey, maybe we have enough capacitance there, right? Anyway, I just like to show that stuff because it looks cool. Let me get back to this software refactoring. So I'm not really comfortable with these names yet, but we can refactor these names. So moving the controller state machine. You know, what if we call this one like next controller state normal? And then we call this one next controller state update firmware. I think I like that better. Okay, this message. It's consumed, right? So there's no real reason for me to borrow the message here, right? We can just take off this borrow and we don't need this at all. right? Simplifies it a bit. Yeah, because this is consuming the message. Okay. Do I want to keep it as a mutable reference to an option or just return it? Actually, I'm already returning the controller state, so maybe this is okay. Hey there, Pobo Mojo. This is the Rusty keyboard. I developed this on stream. It's inspired by the Korn keyboard, which I have one of those already. So it's generally the same layout, although I customized this to my hands. And I've done all the 3D printing for all the plastic pieces, and I did the circuit board design, which I was bragging about a little earlier. Here's what it looks like in KiCad. And I've done all the firmware in Rust based off of the board support package and USB libraries that are open source for the controller I'm using, which is a Raspberry Pi microcontroller. Okay, I think we're good with this module, right? So this is a diagnostic one I don't really care about. I think this one's fine. Heap is fine. Let's skip keyboard. That's the big one I gotta refactor. This is okay, I guess. It's fine. This, I think, we'll need to refactor later. This is only controlling this LED we see flashing there on the controller board. I'll have to refactor this later to include all the code for the new LEDs we're adding. Logger is good, I guess. Oh, I did this off stream and it wasn't in any of the streams. I was using interrupt free for this, but I found that we actually have a multi-core safe alternative using the critical section library, because the board support package for the Raspberry Pi microcontroller actually provides an implementation for the critical section that does a spin lock, which is really nifty. So critical section with is better than interrupt free for my board. Okay, main is pretty short. That's good. Panic we're still not doing anything about. Okay, how about programmer? This could benefit from the same kind of split I did before, right? So split each of these into a separate method. I think I'm going to do that. Extract into function. Okay, and the naming convention I used was next something state something, right? So this would be next programmer state. And we're handling what now? Commit. I can't scroll when we're doing that. Okay, next programmer state commit, and then the next one is forwarding program. Is that right? Yes, and then pause between sectors. Pause between sectors. Okay. Cool. So then the state machine is much simplified. Depending on what state we're in, we're calling one of 3 different functions. And I don't really care about the order of the arguments. Okay. Oh, we have some bugs. So can't find ring buffer size. It might need... Oh, I see. Because it's what? It's a const. Yeah, it's a const generic. So we need to put that in here. We don't need a timer, so let's delete that part. Okay, that fixed it. So sometimes the refactoring doesn't get it quite right. So here it left off the generic, the const generic part. But usually it's pretty good. Okay, that's good. Looking good. All right. Next, ring buffer. We might end up tossing ring buffer because I found out that vecdq actually has a pretty decent ring buffer implementation behind it. Okay, so the elephant in the room is keyboard. This thing needs major refactoring. So actually, you know what I'd rather do? Is just build what we have and make sure I didn't break anything, and then commit that in Git, and then tackle this keyboard. So yeah, I have already written like my own programmer built into the thing. So it's sending the firmware update to this guy, and then he forwards it over the serial port to the other guy, and they both update their own flashes independently and reboot themselves, which they're doing right now. And now they're booting back up. So still working. It didn't crash. Let's move on. Okay, so keyboard.rs. Let me look at the overall outline. I should probably take these key events and move them out to their own module, right? Well, I mean, there are not very many lines of code. Maybe they don't need to be moved out. Where's pin state used? Oh. Okay, they're used for drive row. Okay. Yesterday, reading the online Rust book, you liked the example to abstract state machine as type. Oh, I haven't seen that. I don't know if I've been doing state machines correctly. One thing that's sort of I've settled on is this concept that a state machine has a next function and it consumes self and returns a new self. That way we don't have to worry about the borrow checker, since we're not borrowing the state machine when we go in. The state machine always produces a new machine every time, and if it doesn't need to change state, it just returns self. So I use this pattern a lot actually to avoid borrow checking problems, or where you move it in and move it out of a function. Hey there, Smack in the Box. How are you today? So I'd be interested to see what the online Rust book does for a state machine. Okay, looking for refactoring opportunities. I think I want to take the whole scan keys function, because it's 300 lines. I think I want to put that into its own module. In fact, you know what I'm thinking about doing is, for the first cut here, making keyboard have submodules, and then breaking it in. The first thing would be to break this into submodules. So we'd have a keyboard directory here, and then there we'd add, let's add a scanning, or just scanning .rs, and let's just take all the, like the scan keys, for example, and just move it out. Get out of my way. Okay, so cut that code and paste it here. And this, whenever I kind of do this, what I usually do is I take all of the uses and duplicate them into the submodule. And we'll have to repeat an impl keyboard. And from keyboard, we'll have to declare a module. So module scanning. Okay, and then we have to import some from Super. Use Super Keyboard. Super Keyboard. Why is it implicit elided lifetime not allowed here? I don't know. I think it's just confused. Oh, we have to make it public? Yeah, that makes sense. Split keyboards are wild. Especially when you know that this cable here is transmitting all of the information about all your key presses. Hey there, Mr. Balrog. Yes, the librarian where the books on engine lubricants were. She said they were in the non-friction section. Mr. Balrog's got the best jokes. I don't understand why it's telling me that. I think I'd rather just do a, close this guy. A cargo clippy on this. Usually the first error is the most important. So do cargo clippy and just look at the first error. Lifetime mismatch in self.scan keys. Okay, this is a lifetime on USB. Oh, I see. Keyboard is generic. I forgot about that. So probably at the top of this I'll see that. Yeah, so there's like a USB bus lifetime. Makes sense. So we'll need that here and here. Alright. Okay, so a lot of this stuff gets imported from Super, right? So would it be fair to just import everything from Super? I kind of think so. Where's Super in this list? How come I'm not seeing it? Is it at the top? Yeah, so what if I just include everything from Super? And then, yeah, then we remove all the things we don't need. But there are other things from Keyboard RS that we want to move into scanning. So there's the actual scanning of one key, right? Scan key. So let's move that in there too. Do. Okay. Teaching yourself touch type at 46 is rough. It's taken me about 8 months to switch layers and use this kind of a keyboard. And I'd agree that it is kind of tough. You just have to keep at it. It has to be something you find fun, and I do find it fun to kind of learn a different layout. Don't necessarily have to follow the touch method. For me, I used a printout of the keyboard layout that I have. So I printed this out and I put it above my monitor. And then I would just be constantly looking up and down between that printout and then what I'm trying to type out. It helps for this keyboard that I don't have to move my wrists, so I'm usually only moving the fingers up or down one row, with the exception of the index finger that has to move inwards. So it's a little bit easier that way. Right, fewer keys to memorize. Okay, what other functions do I want to move out of that have to do with scanning? Probably like the driving rows should move out. Okay. And then the reading back, what did I call that? I don't think any of these. I think that's it. Okay, so then scanning, right? Oh, it was called scan key. That's the read. So it's drive row scan key. Okay. I think we only want scan keys to actually do the key scanning. And then I want to kind of move the rest of it over into other functions. So back where we're calling scan keys, let's go find that. Right here. I think after scan keys, we want to call like the next steps, right? So what's the next step after scanning? So that's the scanning. I think we're done. I think the next step would, well, this does debouncing somewhere right here. So scanning does the debouncing. And we get an updated raw key state. And we combine with the other keyboard. Update debounced keys. Oh, what is this? Oh, this is handling keys up and down. So this is where we should draw the line. So this stuff should be moved out to another function. So public function, what does this do? This is sort of like converting the key state into, this is really handling keys going up and down, right? So this would be like handle key presses and releases. Mute self. Don't know what else would need. Delete that key. All right. Okay, we need key state debounced. Oh, shoot. So, is that the only variable? Also, we need key configs. Okay, so, do we need key configs here? I don't think we did. So, this doesn't actually need the key configurations, which I guess makes sense because it's only scanning them and getting something out. But this key state debounced is an input to the next stage, right? There's also a now. But that we can resample, I guess, or now could be an input to it. Oh, that's not what I wanted. I want this to return whatever type that is. What is that type? U64. Well, let's pass in the current time, so we only need to sample it once. And then that means I'm going to move this one out. And I'm going to place it here. And I'm going to give it to scan keys. And then I'm also going to call, oh, we have to return, we have to actually capture here. What did I call it? See, I have the memory of a fish. I can't remember things. Key state debounced. Return the current debounced key state. What do we end up doing with that? I store it here. If the key's changed. I mean, I guess that makes sense. And I think this is where we would call it for that function and then go on to the next function. So yeah, this is where we'd have to pass it in, right? U64, and also it needs a now. Oh, you like the pinky stagger? It's because I have shorter pinky fingers, so the pinky stagger actually fits me better. Also, the thumb patterns are what fit me better. So, when you make your own keyboard, you have the opportunity to customize it for you. And I'm like, I can't pass up that opportunity. I have to customize it for me. All right. So key, I just had it and dang it. I keep flipping away from it. This is the output of scan keys. And then the input to the next stage. So that's handle handle key presses and releases. It gets key configs. Key state debounced in now. And this didn't need to scan. It didn't need the key configs there. Okay. So this should all be happy again. You can write, hello, how are you? 40 times. Just deliberately try to use fingers that make sense and then do the same for the next day. This is effectively how you learn to play melodies on the piano. Oh, how you pick it up? I've been doing monkey type to practice both the layout that I'm trying to use and also get familiar with this keyboard. I went from going from corn to this, I dropped immediately 15 words per minute. So I was at like 85 and I dropped down to 70. But I hope to get back to 85. And that seems to be the ceiling for me right now with Colmac. And I used to do 110 on QWERTY, and that's dropped down to 100 because of my intense training on Colmac. Oh, what is corn? I also have a corn command. I have it, but it's not plugged in. Now that I have my own keyboard, I'm sort of on the verge of retiring my corn keyboard. Anyone want a corn keyboard? No, just kidding. I kind of need it as a backup in case I screw this one up. So the corn keyboard looks a lot like this. It was one of my main inspirations for this keyboard. It's got the same 3 rows. You can have a 6th column on the corn, although some people cut it off. And it usually has 3 thumb buttons on each side for the layering. Okay, yeah, I think we just wanted to handle this. And actually, we can do an early return here. We could say if no keys change, return immediately. And this doesn't update the debounce key state, does it? It doesn't. What this should say something like, what do we want to say? Return early if no keys changed. So if keys changed equals 0, return. And then we get rid of this bracket here. Well, that bracket actually ends the function, so we're going to have a new function here. Which we don't know what to call it yet. Oh, let's see. What do we want to call it based on what we see here? We have this. It's just a hack. Apply meaning of hold tap. So I guess that would be the next one, right? Would be check hold tap decisions. Mute self. Okay. Okay, so this is the next... No, it's the function we already have, right? Okay. I think this actually belongs in the last function. That's a hack for now, until I do the real LED stuff. Okay, so this needs a now also. I'm wondering if maybe now should be moved into self. Oh, it also needs the key configs. Alrighty. Collapse. Paste. Key codes. Where are key codes? Oh, do I define them here? I do. Do I need them? No, they don't belong here. Alright, so that moves down into here. See, refactoring is helping me make the variables apply more locally to where they're needed. Okay, so then back in here, that's the next function we call. So we have, again, the key configs. And now, okay. This is auto importing them, by the way. Huh. I guess because it's in self, we don't need to say what module it's in. Interesting. Okay, so check hold tap decisions should really only go down to here, right? Then we're processing the key queue. So let's end here and make a new function. Process key queue. Well, I already have something called process key queue. In fact, that is on its own, should go back into keyboard. What is this right here? This should be like in queue. Well, what this is doing is saying if we have keys that are held, then in queue held keys that were pressed before the earliest hold start time. So what's a short version of that? Like in queue held keys predating earliest hold time. What a mouthful. And do we need really need the key configs? Huh. Interesting. Okay. So that ends there. This one goes on its own over here. Where are we? Should go to run, right? Wait a minute. Now I'm lost. Was it scanning? I'm lost. Where do we call this from? Poll. We call it from poll. It really doesn't go in poll though, does it? I mean, I guess it sort of. What is poll called? From run? I guess it is polling. Well, I can move it around, right? Anyway, that's where we paste that. Okay, so we need to get key codes out, actually, from an earlier step. Okay, this builds the key codes, right? So then we need this to return key codes. Is this the right way to do it though? Okay, I'll just keep it for now. So then we're going to let mute key codes equal that. So then process, okay. Okay, I forgot the order of this. So I'm gonna undo a little bit and then I'll redo. Okay, so it's after NQ held keys that we call the other one, right? So that means I have to call this one and then process key queue, right? Key configs, yeah. Okay. Getting there. Like 3 major functions left. Line 383 is the same. Not anymore, right? I think I fixed that one. It's very interesting. These are called mechanical keyboards considering there are no electrical keyboards, just mechanical. Yeah, it is sort of a bad name. I think it's to distinguish it between the membrane keyboards. Like, it's the actual mechanism inside the switch. It's either mechanical or it's like as in there's a mechanism, or it's just something that's bending, like a membrane. There are no electric keyboards, just mechanical. Have I been coding my mechanical keyboard forever? It's only been 26 streams, though. I think it's what Tribute Dev is saying. It's just membrane keyboard or not. Yeah. I think it comes down to that. All right, what do we call this one? I think this one is restore or restore modifiers and layers. Or update, it's just called update. Modifiers and layers. Okay, adding that call to here. Sylph, not Sylph. Okay, a lot of these are not going to belong in scanning, are they? Because we're not really doing scanning anymore. This is like keyboard state processing. Well, in addition to the 26 streams, you have to realize I did like a bunch of hours of soldering and 3D printing and other stuff, so I just couldn't stream that stuff. It adds up though. It's like hundreds of hours of time going into this. All to do something that most people would just rather buy a kit or just buy something already manufactured for them. What am I calling this? Set up a keyboard report to be sent if key codes or modifiers changed. I guess, yeah, this is update keyboard report. I can't type right now. It's getting late. I need to focus. Okay, so this takes the key codes also. Key codes. Is this not imported? Oh, it's lowercase. Those didn't take the key codes either? Huh. All right, so that's the last function. Well, next to last. Almost done. I remember writing this off screen. This is how we make all the underglow LEDs on both sides of the keyboard glow green if caps lock is on. Yeah, so that's I want to have that in a separate place. So this is what handle host HID report. Okay. Jeez. Oh, that's cool. It's a nice little numpad. I like the frame, the chassis that it's in, that sits in. Thought most of the 26 streams would be physical building of the keyboard. Well, yeah, there would have been more if I could have streamed the 3D printing and the soldering. I kind of went into it knowing a lot of it would be firmware development because that's what my past streams have mostly been, and also because hardware design is new for me. I'm mostly a software guy. I just found that I wasn't freaking out doing the hardware design. I'm like, I might as well just stream some of that. Cool, so that means we can get rid of a lot of the uses. Up here though, we can't really get rid of a whole bunch of them. We can get rid of some of them though. Okay, we got rid of some of them. Hmm. So this really belongs in its own function, doesn't it? And why are we doing it here in poll? I think originally because we were just scanning keys, right? So how much of this really is scanning? Just this. And the rest of it really should go out of here. This is like processing. I hate using a generic word like processing, but I think I'm going to do it. So processing.rs keyboard will have a mod processing. And then I'm going to just basically copy the entire contents and paste it here. And scanning, just delete everything after scan keys. So all of this stuff deleted. And then processing will just delete all this drive row scan keys, all this stuff out. Okay, there we go. Okay, and there's a ton of stuff we don't need to import anymore. All right. Don't need any of this stuff. Well, I mean, I guess it makes sense we don't need all this stuff. All the low-level hardware stuff makes sense, right? That's this. We're doing one level up from that, so it makes sense that we don't need any of this. We do need B-tree map there, but we don't need anything else from there. I don't see anything that's actually used. Oh, no, we use some of this stuff. Okay, so this we can delete. But I do use pin and pull up and input from GPIO. We don't use the clocks though. That makes sense. Scanning should only really care about this stuff. Yeah, okay. Okay, cool. So now we have a refactored scanning. So it's just driving rows, scanning one key and scanning all the keys. Yeah, combining it to get a debounced key state. Nice. Hey there, Poison. Does what still crash? When were you last here? Has it been a while? It was 3 days ago. I don't remember what was crashing back then, but no, we're not crashing anymore. I can't remember what I fixed, though. No, we're not crashing anymore. Whatever it was, I fixed it. When I fix things, I tend to kind of move on and forget what it is that I actually fixed. Okay, so here we need the keyboard. I'm refactoring right now. Basically cleaning up my code. I output a ton of code, I get it to work, and then I go back and say, well, this looks bad. It's like hard to read, and I need to spend some time like cleaning it up. So that's what I'm doing right now. Since I'm almost done with all the firmware, really the only thing missing is handling LEDs, and I need to actually solder the LEDs in before I can really do much testing there. Okay, so we only used vector. And yeah, there's no hardware abstraction layer stuff in this submodule, so that all that gets deleted. And we only use key codes from the crate here. Cool. So here's the keyboard processing. We have handling key presses and releases. And I think I do need to do another level of refactoring there because it indents quite a bit. Then there's check hold tap decisions. Looks good. In queue held keys predating earliest hold time. Long name, but I think it describes well what we're doing. So we have a binary heap. I think I made it. Right? Yeah, binary heap of held keys, sorted by when you press them down. And we, if we have some, then we go through the hold start times, which is recording the decisions we haven't yet made, and we find like what's the earliest time one of those decisions like periods started, and then we say, well, anything that's being held. The held keys that are being held back, if they were pressed before that time, then we go and queue them. So update modifiers and layers says that if we don't have any keys queued, actually I think I would like to move this out and put it in the caller. Because the decision about when to do that really kind of doesn't belong in a function called just the update should just update, right? So this should just do it. Update modifiers and layers, it just updates them immediately. Update key report. Let's make, again, this one kind of the decision of the caller. That makes sense, right? So then updated key report actually sends it. Well, it doesn't send it, it's update. Update the key report. Yeah. These just do it, and we only do it if it changed, and that's what the caller makes sure. And same thing, right? So this should be in the caller. Yeah, so that we're only doing it if it needs to be done. Okay. Yeah, whenever you have like one of these things where like the entire function is predicated on some if, then you probably don't need that. You probably don't want that in there. Probably want it in the caller. Okay, and we don't need that comment anymore because the whole function describes that. Yeah, what we're doing with the host HID report is we're looking at the first byte and seeing if caps lock is pressed, and if it is, then we light up all the LEDs green. Do I want to say that here? Really, it goes with the whole function. We say light all the underglow LEDs green if caps lock is on. Otherwise, turn them off. That's exactly what we're doing. Oh, also, forward the LED state to the other board. That's what this does right down here. And we're doing an info. That really kind of belongs at the top. Okay. So the only thing I think I really need to refactor is handle key presses and releases. And I think it comes down to there's a block if you press a key down, and then there's a block if you were holding down a key and it was a hold tap decision, and then there's if you release one and it wasn't a potential hold tap decision. So let's refactor those out. Let's take this and hit control dot, extract into function. And this is like handle key down. Let's just say handle key press. Okay. So whenever we see a borrow of a vector, it makes me think that I really want it to be a hash. Oh, that's because of this type, right? Yeah, it really should just be that type, right? Yeah, okay, we'll just leave it the way it is there. Okay, and then follow this back to who calls it. Okay, this one, refactor that. So this is like handle key release hold tap. So a key involved in hold tap decision making. So it's a tap if you released it. I guess we don't need to say the word hold. Yeah, it should just say tap. Okay. And this one's just handle key release. I guess this would be a hold, right? Yeah. There's hold and then there's tap. So a tap means we have to press and release it really quick. If it was hold, then we just release it. I like it. So that looks a lot better. It is a little bit indented, but it's probably okay. Then we have that hack in there. What else can I do with this? An early return. Just make sure I didn't break anything. Program. There's our programmer output. Aren't you all riveted by it? One thing that slows it down is the serial port, because I only run it at 115 kilobaud. Ba-da, ba-da. Okay. 30-second delay because of that bug we haven't fixed yet. Okay. Everything seems to be working still. Caps lock still work? Yes. Okay, cool. Then I'm gonna check it in. Oh, I forgot to check this one in. Let's check that one first. Okay. Not cargo, git commit. Add config.bat for updating keyboard configuration. Updating config's fine. Okay, and then update. You can do it. There it goes. So yeah, this rest of this is like refactoring. So let's just check it all in together. Refactoring. There are two main things I did, right? So extract individual state machine arms into separate functions. And the other one was to split out keyboard scanning and processing into submodules and smaller functions. All right, I think that's it. Whoops. If I type too fast, it ends up going into this window. Git push. All right, let's go back to keyboard.rs. This module still is kind of long, so maybe I break out more stuff. I kind of want polling to go. Polling can do like the scanning of keys. Maybe. I don't know. Maybe we leave polling the way it is. How about the individual parts of polling can go into a submodule called polling? Like we have poll log, we have poll peer serial, poll USB, process, yeah, all of, well, and the process control input can go into its own submodule too, right? Process key queue. What's that doing here? This doesn't belong here, does it? Oh yeah, this should have been moved. This should go under processing. Let's put it at the end. Public. Hold on, what? Is it probably just telling me I have a duplicate? Yeah, so I just need to delete it. I just need to hit save here. There we go. All right. Back to here. Activate key, deactivate key. They're called from processing, right? Yeah, so those should move into process. How big is processing? Not that big. Okay, cool. So these should move. So that should go, I guess, to the top. I'm going to want to eventually sort these. Losing my voice already. So, a tip for people who are going to be streaming is to make sure you have water and keep hydrated, because it'll help you not lose your voice. Deactivate key goes here too. Cool, and it's good that I don't need to make those public because they are only called from processing, so that makes more sense, right? Alright, so then anything else that needs to go under processing? Poll? No, that's actually looking pretty good. And queue held keys should go, actually. Yeah. Okay, good. And then, what are we down to? 800 lines? I think I am going to make a polling.rs. Okay, and then keyboard will have a module called polling. Okay, and then let's just copy everything. Copy and paste, save. And then going to be a lot of deleting down to the impl of keyboard. All right, and then we need to use super everything. Okay, so let's delete what shouldn't be here. Blink LED, get key config, new, all that gets deleted. Poll. Actually, poll, let's leave in the main one. But these like individual sub-functions will move out. Process control input actually should belong here. This can go in the main one, so should run. Okay, yeah. That's what I want in there. Just the polls and the process input. Okay, so then these all need to be public. Actually, just these three. Process input doesn't need to be public. Alright, and then back in keyboard, we need to delete those same functions. So find them here. And then we're going to delete them. Cool. And so now that frees up some of these things that we don't need anymore. Really? We don't do any logging from here anymore? Wow. Okay then. Cool. And then, yeah, polling has a lot of things it doesn't need. Okay, so yeah, all of this stuff. Okay, we use USB device state, but not device or device builder or the class preludes. Okay. Cleaning up the imports, so don't need any of this stuff. Yeah, we shouldn't need any low-level stuff, right? Yeah, all of this goes. Okay, we do need the programmer, but we don't need this. And we use save but not load. Alright. Now what are we down to? 600 lines. And then polling has 200, processing has 400, scanning has 100. Okay, that's a good split. There's maybe a little bit too much in the main one here. There is a lot of lines for imports and then the main structure definition. I mean, I could break this out into a submodule, I guess. I don't know. This is sort of the main module, the God module. Actually, a lot of this hardware init. I think the hardware init should be in a. Let's put it in a module called init. Yeah, because then a lot of the low-level hardware stuff will end up going in there, right? So then, actually, that's not true because we still need a lot of those type definitions for the structure definition. Yeah, a lot. Well, let's see. Let's see. So we'll make a new one called init.rs and go back to keyboard. Make a mod init. Copy everything into init. Paste. And then starting from the module stuff, delete down to the impl keyboard. Okay, and then we're going to delete everything but new. Okay, and then collapse new. Delete everything else below it. Ah, hit the wrong key. Okay, so we just have new. So we need to do use super there. Okay, yeah, I need to delete the new from keyboard. Okay, let's find it. Okay, so delete it. Yeah, this is for the keyboard I'm actually typing on, Sanacron. I almost slipped back into using my other keyboard. Yeah, so over the last 26 streams, I've made this from parts, in the software as well. So, started with the KB2040. Again, I almost typed on the old keyboard. You know, the later and later it gets in the evening, the more mistakes I make on the keyboard. I started with that and other parts and the board support package for that board. And I started with also the Rust open source USB stack and the NeoPixel libraries, and I wrote everything else. Slip-ups are hard to avoid. Better to ship your previous keyboard to Africa. I'd still have that previous keyboard that you might have seen, the 12 key one. Maybe turn it into like a Stream Deck or something. Okay. Alright, so we got rid of some of these imports. Yeah, so today I am mostly refactoring the code in my the firmware for the keyboard. Using the keyboard to do it, ironically. I think the next stream is going to be playing with LEDs. I will solder the LEDs on, and then we'll be doing the firmware for the LEDs. So my thought is kind of like what I had on my Korn keyboard. We'll make it so the LEDs light up as I touch the keys. So, and not like just completely off to on. We'll have it go through a range of colors and intensities the more we press the keys over time, and then we'll let it decay when we stop pressing them. Okay, so that is the main keyboard, and then the init. Just deleting imports that we don't need now that we split the code up. Looks like I don't need any of this stuff. Why is it using log filter? I don't... Oh, because it sets up the log. Duh. Yeah, I forgot about that. Okay, so we need some of this stuff. You need the GPIOs, really? There... Oh no, I do need them. Oh no, I broke something. Shoot. Ah. Undo a little bit. That's what I broke. I can't get rid of that quote, that brace there. Okay, don't need any of the GPIO banks. Okay. Don't need the clock. Don't need ring, buffer, reader, writer, programmer, flash, or controller. Okay, cool. So the init takes up a good 250 lines. Keyboard is now okay, cool. I think we're done refactoring. So the main keyboard has the structure definitions, and it has some of the general purpose ones, and it has the main poll and run. And from there, poll or run calls poll, and poll breaks out into scanning and processing functions, and init is by itself and handles all the hardware setup. Okay, I like it. So let's make sure it still builds. You're planning to solder them online? I don't know. I don't think so, because the soldering station's in the garage and I don't have a camera set up there. But what I was thinking about doing is try to record it on my phone and then include it in the, what am I gonna call it? The highlights video. I'm gonna make a highlights video for YouTube where I go through the entire project from start to finish and try to fit it under an hour. And I think I'll try to include some of the soldering in that, maybe. The diodeless keys are nice. Hey, there's one that I really liked that I got a lot of inspiration from. It's the Pinchy. And I have a command for that. That's a diodeless keyboard because it uses the Raspberry Pi Pico, and that has an amazing number of GPIOs on it. Enough to have one per key, even with this many keys. Oh, I've missed some other chat. How does the key feel for you? It feels really nice because I set up the positions of the keys according to how my hands feel on it. So a few things I'm still, like the inner thumbs, I think I might have made them too far up. I might want to, if I were to rev this board, I might move the thumb keys down a little bit. The outer thumbs are really nice. The middle thumb is maybe a little bit too high, and the middle thumb is a little bit too high, and the inner thumbs are, I think, are even more a little too high. So I might bring these two keys down a bit. Okay, I think I answered everything. So let's program it. While it's programming, I guess I'll do check-in. Oh, I can't do that. I already have the window up. So let's quit that and run it again. All right, so we're reprogramming now. So let's. Oh, I shouldn't do that when it's reprogramming. I shouldn't be using it because they can get out of state. Okay, good. I was worried that I messed up the programming, but I don't think I did. Okay. Well, it's still working. So, oh yeah, I need to stage it first. Good sanity check is I can still use it after I've reprogrammed it, right? So this is refactoring. Split out init and polling submodules of keyboard. And then what did I do with oh yeah, some functions needed to go in processing, right? So move more processing related functions of keyboard out to the processing submodule. Like I did again. If I type too fast, it goes in the wrong window. Pinchy, it does seem really nice. And the authors of that one didn't do as much stuff from scratch like I do. They used Keyboard, which handles like the debouncing and the keyboard layout stuff. So their code is actually a lot smaller. Oh, where's up? I mean, just these keys. So like if I were to show you on the PCB design, I think what I would like to do, let's view the front again. front layers. I think what I would do if I rev this would be to take this switch and move it down to here or so, and make this one move it down to there. I think that's what I would do if I rev this board, is move those two thumbs down. Running hardware unit test. Okay, exactly. So far, I like the placement of all the other keys. They feel really nice. It's just these thumbs, I think. And yeah, I think I made a little bit of a mistake with these. They're being a little bit too high. But it's not too bad. Oh, the other mistake I made was I didn't have enough clearance on the bottom side, by the way. I think I talked about this before, but if I were to flip the board view again and show the back layers and hide the fab layer. So, for example, right here, this is the plated through hole for one of the screws, right? And I think if we measure this, we'll see it's like 2.5 millimeters. Well, it turns out that for the 3D plastic part on the bottom here that has the columns that have the nickel inserts that the screws screw into, they need actually 3.5 millimeter radius. So it has to go out to here. Actually, I think it's more like 4.5, like 4.5 millimeter radius. So in a circle of 4.5 millimeters, there's plastic butting up against the bottom here. Well, the problem is on this pad, I actually have that, if I just click there, I have the socket goes all the way out to like halfway through the pad. So there's an intersection between the plastic and the metal piece. I've had to shave off plastic, and like right here, I have to shave that off. And I think on the left it was okay. Yeah, see, I have enough clearance to that diode. But like right here, I'm pushing it. Like I'm getting pretty close to that LED up there. Yeah, here's another case where I don't have enough clearance between the pad, this pad, and then the plastic foot underneath. It was butting up against it, and I couldn't get the screws aligned. So the other thing I would do if I rev this board is move these screw holes a little bit more. Like I do something like this. I take this guy and I move him over to here to get like equal clearance from all things. That actually might be too close to the diode. No, that's okay, because I just need to put a wire through there. Hold on a second. All right, one of my kids said goodnight. So yeah, I'd do that if I were to rev this board. Give myself a lot more clearance around these through holes. Anyway. Okay, so we're done. I think we're done refactoring for the night. Close that off. Pretty good shape, I think. Hey there, RW Grim. How are you doing? I was just doing some refactoring today on my keyboard. And I was showing like the circuit board design and some of the mistakes I made in it. So this keyboard you see in front of you, I made this. On over there, you see the circuit design in KiCad, PCB editor, and the plastic around this I 3D printed. The keycaps and the switches are just Cherry MX browns with just some generic plastic keycaps, nothing impressive. So there are really 6 different 3D printed pieces. There's the bottom plate, there's the one that goes around the switches, and then there's these caps for the controllers so that they're protected from dust and spills. And I made some mistakes, but I got around them, and we have an operational keyboard now. I have almost all of the features done on it. It has a lot of the same features you have on a Korn keyboard, so there's layering and modifiers. So like this is A, but if I hold down this key and then hit that, it's capital A. Or I can do a one-shot mod, press that, and then press this, it's also a capital A. If I hold this one down, now these are numbers. But if I don't hold them down, they're letters. So I did all the firmware for that, and today I finished up with a way to actually change the keyboard configuration without updating the firmware, and then I started doing refactoring. So I hope your stream was pretty good, Grim, and let me know if you guys have any questions. I'm almost at the end of my stream, though, so we'll have to rate someone else. No fanning up for pinkies? Nah. In fact, a lot of Corn keyboards have the 6th column right here, and I don't like that. I don't like the pinky going way out. I moved the pinky column down because my pinky fingers are shorter, and so it actually feels more natural to have them curve way down like that. You stick to the QWERTY keyboard? Well, we could put QWERTY on this. It's just so you don't have the number keys or arrow keys. So if I hold down this one, then these 4 here become the left, right, up, and down. And I've seen other keyboards where there's a mouse layer, where if you hold down one of these other thumbs, then these actually, if you hold them down, the mouse goes up, down, left, and right. That's a little bit too extreme for me, though. Take a look at the Dasbob and Ada Ducks keywords. You posted links earlier. They also tend to fan out all fingers. Okay. Yeah. So one of the benefits of designing your own keyboard is you get to make it match your particular hand shape, and so that's what I did. You spent hours debugging code you copy pasted that needs to be removed. I kind of did something similar to that. I copy pasted code out of my keyboard.rs into these submodules that are sort of a division of the work. So now my main keyboard.rs is pretty short. And so it roughly divides into, we initialize our keyboard by grabbing all of the low-level stuff. So the peripheral access crate, the watchdog, I think this is the serialized I/O. Here's the clock setup, so really low-level stuff, right? The main timer, the raw pins. Here we get set up like which pins go to our UART. Here's our peer-to-peer serial port. Here are the rows and columns for our keyboard scanning. Here are our pixel chains. We have 3 of them. We have the one that's built into the controller board. We have the ones that are under the switches. So like I have one test one that's soldered in. If I hold down that one, it turns red. Isn't that cool? And then we have the underglow ones. So see, no light there, but if I turn on caps lock, now there's an LED lit up there. So I have one mounted, and I need to solder the other 3. So there are NeoPixel chains. Anyway, we do all of our hardware setup in init, and then there's a main polling where we have to poll a certain subset of things. So like we poll a ring buffer with our diagnostic log, and then we'll write it out to the other board if it's on the right hand side. And then there's the serial port between boards that we have to poll, and we're moving data in and out of ring buffers and hardware FIFOs there. And then the USB is the really fun one. Here's where we go to our USB stack, and we have keyboard reports, media reports, and a serial port. The serial port's really handy because we can get all our debug messages out. So again, I have some like ring buffers in play here that we're pushing and pulling from, and we get what is it? This is where we know if caps lock is pressed or released, because we get a report from the host. And where is the part where we push? Right, if we have a new keyboard report for the host, we write it out there. And you're right, there's a separate report. I learned this the hard way, that if you want to do media keys like volume up, volume down, it's a separate report from your normal keys. So we have that, and then processing is really complicated. This is how we handle stuff like one-shot mods and sequences where you have to hold down shift and then press a key. And just the overall, like, what do we do when we activate a key? So a key could be a media event, a normal key code. It could change the modifiers. It could be a combination of key code with modifiers, and then we break it into the 2 halves of that, key code and modifiers. Layer switch, one-shot modifier, one-shot layer, and a toggle alternate config. That's so we can switch between Mac and Windows for some keys. And then the real cool stuff, I think, is the scanning stuff, where we do this like 35,000 times per second, right? We will, for every row, we will drive it low, and then wait for it to electrically settle, and then for every column, we'll scan it, and we form a huge bitmap. So scanning is nothing more than just checking a column input to see if it's low or not. And it all harkens back to our schematic. This is the basic keyboard matrix, right? So one at a time, you drive one of these rows at a time low, and you see which columns go low. The column will go low only if you're driving the row and someone's pressing, the human operator is pressing one of the switches, right? So that's why we call it a key matrix. It's a matrix of rows and columns, and here's the code behind it. But it's not enough to get a bitmap of which keys are held down. We also need to perform debouncing, so we do that down here. I have a nice thing in my notebook that kind of covers that. I put it under notes, I think. Yeah, so what you'll see a lot with like hardware switches of this nature is that there's not a clean transition from being released to being pressed. You get a kind of a noisy signal, worst case. And so a debouncing algorithm smooths it out into a nice, it wasn't pushed, and then it was pushed, and then it wasn't again, by just waiting until the input signal settles on both transition from 0 to 1 and 1 to 0. Right? So this state machine does that, right? It's pretty, I like this a lot because it's pretty simple. It fits on one screen. We have a B tree map, so it's a container of timestamps of when each key last transitioned, and given, I think, every key? Yeah, for every key, we see, well, is there an entry in there? If no, then, well, did our state just change? Then insert the current time. If there was one from last time, we say, well, did it change again? Then we remove it. But if it didn't change, if it stays stable for the debounce time, then we can finally flip the bit in the debounce state. So this does a pretty good job of debouncing. How are tests coming along? Pretty good. I don't think I have any bugs other than the 30-second connect time. We still have a problem with, sometimes it takes 30 seconds to connect to the keyboard serial port, and I have no idea why. It has something to do with when it's setting the line configuration. And I looked at the code on both ends, and I can't figure out why there's a 30-second delay sometimes. But yeah, so today I've refactored this out. It's really nice because I can now focus on any kind of the firmware. Like if you ask me how does the programmer work, I can just find programmer.rs and show the different states of the state machine. And here's the last one where we actually make the LED turn red, and then we go into the final stage of reprogramming, which is to copy from RAM into flash, and then go into an infinite loop because we have set the watchdog timer up to reboot us at the end. So I don't know, cool stuff. Did I get any more questions in chat, or am I done? Seems like 99 of the previous code was having a multiplier of 1 million, so perhaps one of those takes all the time when connecting. Oh, did we have a 1 million? Hold on. Oh, this 1 million was just to compute how many scans per second, because 1 million is the period of the timer. Yeah, as we see here. I don't know where that 30 seconds comes into play, though. This has nothing to do with it. That's just the address of flash. Yeah, so this, I should make a constant for that. That's the timer's frequency. Let's do that. Let's make a proper constant. So const timer frequency. hertz. I think the type of this is U64. Actually, this ought to be global to the keyboard, so let's move that up to keyboard and paste it there. Sure. Actually, oops, hold on, I messed up. Meant to cut on that one and then paste here. There we go. Okay, and then, yeah. So let's look for 1 million again. Whoops. Yeah, so we can use that, just making sure. There we go. Now it makes more sense what that 1 million is. And then we can do the same thing here too. Copy that. This will need to import it. Oh, well, I need to make it public here then. See, I get a lot of feedback from chat, either directly or indirectly, that helped me improve this. And now it's more obvious what that number means. That it is the timer frequency in hertz. That is your contribution. Thank you, Hittis. You have a good night too. So that should have been the only change right there, right? Okay. Yeah, we're going to be ending soon because I'm running out of things to do before I go solder some more to put the LEDs on. So we'll see. Give a proper name to the timer frequency. Constant. It just barely fit. Cool. All right. So who else is streaming really cool stuff? Oh, nobody. Okay. How about in our category? Browse. Software and game development. Okay. Huh. Someone doing music production. That's neat. I don't know what PPY is doing. The stream never really tells me. Just says dev continues. I don't know what that means. I need to start watching some of the other streams in this category because I don't know a lot of these people. Okay, I see someone else who's streaming, but looks like they're about to raid someone else. I hope they don't raid me. Don't raid me! I don't know. I think we just end the stream. I can't just end the stream with 59 people watching, though. Race to raid. Should I just raid him then? Okay, we'll raid him. Let him figure it out. We're gonna raid Quantum Apprentice. Hopefully he doesn't try to raid me. Alright, Quantum Apprentice, friend of the stream. He's working on I Am GUI. And hopefully he's not ending. If he is, he'll have to raid someone else. So I'll be back in a few days after I solder some more LEDs on this thing, and we'll play with those at that point. Thanks for watching. Have a good rest of your day or evening. Bye-bye.